Available within the Java programming language. You should already have had exposure to arrays in the VTC course Java 7 Language Basics, so we will quickly be reviewing it in more depth. An array is a group of variables, called elements or components, containing values that all have the same type. Arrays are objects, so they're considered reference types. As you'll soon see, what we typically think of as an array is actually a reference to an array object in memory. The elements of an array can be either primitive types or reference types. To refer to a particular element in an array, we specify the name of the reference to the array and the position number of the element in the array. The position number of the element is called the element's index or subscript. Here's an example of an array with primitive types. We'll call it C. Here's our primitive type array. Here's an example of an array with reference type. Now let's look at different ways of creating and initializing an array. First, let's look at just creating an array with a certain size. The elements of the array do not have a value at this point. So here we are declaring an array. And then here we create the new array object. We can also use an array initializer. You can create an array initializer and initialize its elements with an array initializer, which is a comma-separated list of expressions called an initializer list, enclosed in braces. Let's see how this works. So here, as you can see, we have the array. Instead of giving it a size, we're going to actually put values in it. In this case, the array length is determined by the number of elements in the initializer list. So the length of this array would be 1, 2, 3, 4, 5 elements. Now because we start at 0, when we loop over it, we'd actually begin with 0, 1, 2, and 3. Now let's access the values of the array elements. First, we're going to create a for loop with a counter that starts at 0. We're going to make it less than the array's length. And we're going to increment the counter every time it comes around. We're going to format the output so that it's readable using the printf method. Let's run our code real quick and see what happens. Okay, here we have the position, and then we have the value. So at position 0 is 10, at position 1 is 20, so forth. Another way of accessing the values of an array is using the enhanced for loop, or for statement. The enhanced for statement iterates through the elements of an array without using a counter, thus avoiding the possibility of stepping outside the array. Here I have code already written. We have a system.out printf with headers, position, and value. This is the enhanced for loop. It will look much different. As you can see, the expression here actually creates this variable number with the value of the element in the next position. I'm going to format the output. And output the number. Let's comment this out. And now let's run our program. As we can see here, without the need to access the position, this expression actually gives us the values. The enhanced for statement simplifies the code for iterating through an array. Note, however, that the enhanced for statement can be used only to obtain array elements. It cannot be used to modify elements. If your program needs to modify elements, use the traditional for statement, which is the counter-controlled for statement. This concludes our discussion of Java arrays. Types to a method, available within the Java programming language. You should already have had exposure to passing data types to a method in the VTC course Java 7 Language Basics, so we will quickly be reviewing it more in depth. Two ways to pass arguments in a method calls in many programming languages are pass by value and pass by reference, also called call by value and call by reference. When an argument is passed by value, a copy of the argument's value is passed to the called method. The called method works exclusively with the copy. Changes to the called method's copy do not affect the original variable's value in the caller. When an argument is passed by reference, the called method can access the argument's value in the caller directly and modify that data if necessary. Pass by reference improves performance by eliminating the need to copy possibly large amounts of data. Unlike some other languages, Java does not allow you to choose pass by value or pass by reference. All arguments are passed by value. A method call can pass two types of values to a method: copies of primitive values and copies of references to objects. Objects themselves cannot be passed to methods. When a method modifies a primitive type parameter, the changes to the parameter have no effect on the original value in the calling method. Here's a pass by value example. The printed value will be 2.0 no matter what happens inside the method changeMe. So here I declared my value and my variable that I'm going to be passing to my method changeMe of type double. As you can see here, the value is 2.0. It's going to be changed here in the method changeMe to 345.0. This has no effect on D outside of this method because the double value is being passed, or in other words, being copied to the method. The value is never passed back. It's only changed within the method because it's actually given a copy of the variable. Let's run it and see. As we can see, D equals still 2.0, even though it was passed to the method changeMe. It was never changed in the main method. Now let's do a pass by reference example. Here we have a car object. Our car class that we will use to illustrate the call by value of the object reference. The car object has an attribute of speed of type double with getter and setter methods. Now let's create a new car and set the speed to 65. So here I have my new car. Now let me set the speed to 65. Now let's try the method change car parameters and pass a Lamborghini to it. I already have it here waiting for us. The system.out.println is going to access the method getSpeed, and we're going to see what the value is. The method change parameter gets the car object and is going to change the speed to 200. So it began at 65, and when it's passed to the method, we're going to change it to 200. Let's see what the output is. The code prints out 200. Why? Because the Lamborghini was a pointer to the object car. The Lamborghini got passed by value into the method, so a copy of the pointer got passed into the method. But a copy of the pointer still points to the same object, the Lamborghini. So changes to the Lamborghini in the method are felt outside the method as well. Let's try another example using the method changeCar, which tries to create a new car and change the value passed into the method. Here's the method changeCar. We're going to pass in our Lamborghini object, and when it arrives here, we're going to actually use this reference by first creating a new car, setting the speed at 75, and then using this reference here, we're going to add the new car to it. And we're going to see that it does not affect the car outside this method. Let's run it and see. So here we have the Lamborghini. We pass it into the change car, try to set the speed on the new car, the Ford, to 75, and actually set the Ford car as the Lamborghini car that was passed in. Now the question is the original Lamborghini object now a Ford outside of the method? No. Inside of the change car, we changed the original pointer to a new pointer, but the original pointer was passed by value. So changing the pointer within the method has no impact on the original pointer outside of the method. This concludes our discussion of Java passing data types to a method.